and also this one. Great. So,
okay.
welcome, Andrés, and take it away.
Okay. All right. Okay, guys. Well, let's kick off with this course. And basically, the course we're gonna talk about basically 5 main topics. So first, I want to tell a bit about the circular economy. Then we're gonna move to the implementation of good sustainable practices. That's gonna be like the major topic of this course. And then I'm gonna talk a bit about the environmental legislation. As a third topic, the fourth topic is gonna be the preparation for audits by the municipality environmental units. I think that's very useful for you guys. And the last topic, which is I believe like the most complex one, is to give you an overall information about the beverage industry climate initiative that is being enjoined between Systembolaget and the Swedish Brewer Association and some other associations as well. So it's basically these 5 topics. And so let's start first with circular economy. As you can see, let me just acknowledge this. So basically, our brewing, the way how we do brewing, or the business has been running, most of the history has been in a linear way, which, as you can see on the right-hand side, is like basically we are sourcing our raw materials, our goods, we brew our products, the consumer consume our products, and they just disposed, the packaging, the bottles, cans, and the secondary packaging. But in relation to this topic, there is also the concept of circular economy, which means that which is old news, I guess, for all of you guys. It's just the same thing. You source, you brew, the customer consume it, and then all this waste can be reused or recycled. So that's basically in very simple words. So when it comes to the circular economy, it sounds like it's an obvious thing, it's like old news for all of us, but the important here to make that happen, for real, is it requires quite an effort, no matter the size of your brewery. And if you want to bring it really to the next level, to really create a true circular economy, it's very important that you collaborate with your suppliers mainly, especially your raw material suppliers and your packaging suppliers. And if you want to run, any environmental or project, and you don't have the means, it's very important also to talk to the governments, to your local municipality authorities, and always institutions that you can raise funds for that kind of project. What is all this concept about circular economy? So, first of all, so brewers, we need to, in whatever we do in all our operations, we will try to prevent waste. That's like rule number 1. So, and then to rethink how we are using, as they call it, abiotic materials, which means that it's all those products that they are not derived from living organisms, like yeast, and which are actually the main contributors of pollution, and obviously also the greenhouse gas emissions, and of course the environmental impact, in general. So how we need to think how can we reuse them, even if we can recycle them. So the packaging, as you can see on the slide, the spent Kieselguhr, or also to think how we are dealing with our byproducts during the brewing process, and mainly yeast, spent yeast, and spent grains. So when it comes to the end of life of abiotical materials, this is something that I will be very repetitive in this course, because it's pretty much, this is the core of our main impact to the environment, is the packaging. So as you can read, the packaging is the largest contributor of greenhouse gas emissions. So we need to work a lot, no matter the size of the brewery, a lot on this. And as you know, guys, packaging, if you look carefully to your production cost, in general, in your brewery, the packaging is the major contributor. Actually, these days, brewing is not really the major expense. Actually, it's more the packaging. So it's something we really need to work hard on that in collaboration with your suppliers. And so here, just some points. You can read it on the slide, but the only thing I used to stress out is just the reason why is this trend of using more cans, which all of us we know, it's just because environmental reasons. Also, like and as you can read, it's like 10% decrease in mass of the glass bottle. You can reduce a carbon footprint, which we will talk about later. What is the definition of carbon footprints and how can you measure them? But here it's just about from 2-ish to 5%, which is significant. Obviously, aluminum cans are a better option. When it comes to another abiotic material, so it means the spent of filtration aids like Kieselguhr, it is known that also is a major contributor to waste and disposal, and has an impact on the environment. So here, basically, the message is that brewers, basically most of brewers, from medium-sized to large breweries, they are dealing with Kieselguhr, filters. The reason is because they are more cost-effective than using another setups, another type of technology. But in this case, for craft brewers, most of them either they have no any means for filtration or for clarification, just exclusively using clarifiers. But I would say for breweries that they produce above half million liters a year, they very likely might be dealing with separators, as they call it now, which is basically centrifuges, and which are environmentally more friendly, and also they give you the flexibility to deal with different type of haze, as you know. And the only limitation that you have for the process itself is that if you really want to get a very crystal clear beer and you only dealing with a beer separator, you require a longer beer conditioning, as you know. So and that's something that you need to evaluate. Now we are talking exclusively about environmental issues and also production costs, because time is money, So the longer you leave your beer in the tank, it's more consumption of electricity, the cooling system, and so on and so on. So this is a evaluation you need to have, to balance out between your cost and the quality of your beer. But again, the point here is just to encourage more the brewers to use more separators, centrifuge. Also, you can use closed flow microfiltration, as you can read, so that they can be of help. But if you really want to have, as a normal production site, with a good flow of your product, is very, very likely that you will need microfiltration units or a pasteurizer. Now, when it comes to that, you need to also think of the evaluation of how much is the contribution of energy consumption and the environmental impact of having this additional additional equipment in your brewery. By the way, guys, I didn't say before I kick up, please, if you have any questions, please interrupt me. I'm very old school guy, so don't write me messages. Just raise your voice and anytime you like, and just to if you have any questions, and I'm happy to answer. So here, when it comes to biotic materials, which is also very relevant in brewing, as you can read, obviously, obviously, as you know, the main contributors are the spent grains, the hop drop, or hot breaks, and the spent yeast, and well, obviously together with the spent hops when you are dry hopping. So many of this information I know is so new for you guys. I mean, here the exercise of this course, or is just to provide you some new ideas or perspectives, or actually experiences, personal experiences that related to this subject. So what you can see here is, well, as you know, the spent grains can be used for animal feed or for composting. The hot drop can be used as a fertilizer. Why? Because, well, it's rich of proteins and minerals and some other macromolecules that can be used for the soil. And but also there is another type of applications. In the case of barley rootlets, in this case, this is more addressed to maltsters, but also it's good for you to know is they are also rich of proteins and fibers. So these ones, they can be used obviously for animal feed industry, but there are another more interesting applications as well. For example, for extracting enzymes and antioxidants, and also can be used as a biochar. Now, this is so there are some companies, even related to brewing, they can extract enzymes using for brewing applications, just exclusively coming from malt barley rootlets. So somehow it's sort of a circular economy as well. Another application using brewing waste, spent hops or hot drop, can be fraction. I mean, especially like when you're dealing with high levels of dry hopping or late additions, you might hear soon, or probably you're already aware, in the US there's just hop suppliers, or also they call it, or for essence and extract suppliers, they are extracting terpenes. Okay, so now they're selling terpenes. Terpenes is their flavor active compounds that I guess you are familiar with. They are in higher levels in American hops or South Hemisphere hops, and which contributes to all these pleasant aromas that brewers are looking for, that can be from citrusy, floral, fruity, tropical notes. So now they're selling terpenes in extract just to add it into your beer, straight to your beer, like instead of adding actual dry hops. So I don't know if you guys have experience. I had the opportunity like 3 weeks ago in the States. I saw those products. I taste some products, some beers using those terpenes. And yeah, the tricky part of these products is that you can get the aroma, but also you can get, when it comes to the taste, it might give you a bit of, how can I say, like a solvent-like kind of flavor. So it's something that you need to work out in your recipe when you're dealing with these products together with your dry hops. So I would not advise using it 100% just for replacing your dry hopping. Well, when it comes to another application is using the spent yeast, which, as you know, we produce quite a lot of spent yeast in our production, and they can be used also for marmite. Of course, they've been using this in the UK, but also again, it's rich also in proteins, yeast. As you know, guys, there's a lot of this products that they are for energy bars, energy products. They are also rich on proteins. They use normally yeast because it's the cheapest source, and but also can be used as a fertilizer. The same as hot rod. And now this is one of the main things or contributors, the spent yeast in the breweries, and especially for small brewers that they are dumping the yeast down to the drain. This is one of the main contributors to increase your BOD of your wastewater, and also has a big impact on the CO2, the greenhouse gas emissions, which I will explain you more in detail, that are reported in carbon dioxide equivalents. But anyway, I will tell you more in later about how you get credits as well when you are calculating the total CO2 emissions in your brewery. What else? Of course, greenhouse gases, which you need to look at in your brewery. I mean, what is we're gonna go also this in detail. What are the main contributors of the main greenhouse gas emissions during the entire brewing process, and not just brewing, also your malting and everything related to production of beer. But as you can see here, is obviously the agricultural suppliers, your brewing activities, but the largest again is the packaging production, and obviously transportation, logistics, and cooling your final products, for your end consumers. What else? Well, I think the other bullet points, I think, is things that you already know. Obviously, also when you are, cultivating barley, is the application of fertilizers and electricity and and fuels used for the equipment just to cultivate the barley, but also the reducing of tillage, which is the preparation of the land. That also can be a major contributor of greenhouse gas emissions. And for us, also, it's important in our process that you keep an eye on your water consumption. That's obvious. This is all news for us, and how much wastewater you are generating in your process. Here, I just wanted to show you some examples. Obviously, all these names you see here, they're large breweries, but just to give you what is like the state of the art, or the things they are doing, the largest breweries, how to deal with this subject. So Heineken is known to be from the largest global companies, like, who focus more on sustainable practices, I would say, probably also together with Carlsberg, and so they're using 100% green energy. Carlsberg, well, you can read here, also reducing 90% of wastewater. That's nothing new, but there are some others, smaller breweries that also dealing with. They're approaching this subject in a more creative way and an affordable way, so you can consider it for your own brewery. And well, basically, it's just trying to find how to recycle. Pretty much is how to optimize your energy consumption, and how to deal with your waste, mostly your biotic waste. Yeah. So how can you, obviously all these words I just say right now is very general, but if you really want to go very in depth, how to go through this circular economy, the EU established a comprehensive policy framework, which is called the European Union Circular Economy Action Plan. Obviously, this presentation will be shared with you all, so you can look it up, and they will give you step by step, how to give you guidelines, basically. How can you apply all these guidelines into your brewery, you know, no matter the size of your brewery. So that was about circular economy. I want to talk now about to implement routines to ensure good sustainable practices. So first of all, we need to look at to the entire picture. So you will see here on the bottom of the slide, there is a very useful document, which is the Beverage Industry Environmental Roundtable. They call it BIA, and you will in this document pretty much I use a lot of this material, but also they will give you very insightful information how to understand this subject, and also how to give you ideas how to implement this in your process. So when I say we need to see all the picture, we need to look at from the beginning how we are sourcing, you know, how the master is sourcing the barley, you know, all our raw materials, and what are the main scope when it comes to environmental impact. What is the main sources of that are having a negative impact on the environment. So as you can see here, as I mentioned earlier, so it's when it comes to cultivation of crops, barley or hops, or cereals, brewing cereals, is pretty much, you know, electricity, thermal energy, you know, emissions, consumption, the use of fertilizers and pesticides also has a big implication, and obviously the irrigation, you know, the water consumption. So which I will talk about later, about the big impact on this when it comes to hops. Okay, so it's something I would like to share with you later, the message how to reconsider your dry hopping levels, basically. The other thing is, okay, to try, besides of the cultivation of the crops, to look at what are really the impact on the environment when it comes to malting, for instance, or the processing of hop products. Because sometimes, I mean, let's face it, as a brewers, sometimes we don't care. We just get you know, news from our hop suppliers. We have a very, you know, nice hops product, and now we have an extract and Dynaboost. You're gonna save money, all fantastic. But also you need to think, or to ask them, how they come up with that product. I mean, environmentally speaking, what is the impact on them, you know, and to understand what is the energy consumption they're using to get to that product. So and so the same goes with malting, you know. I don't want to. It's not a criticize to malting, to any masters, because I mean, malt is obviously malt. I consider as the heart of the beer. It's not hops, no yeast. It's the malt, the backbone, together with water, of course. And but we need to face it that malting is one of the major part of the process, the most energy demanding process, one of the most energy demanding processes in the entire, you know, brewing, well, as a whole picture, you know. So it's important to understand that, you know, and obviously because this implies the steeping, which requires high levels of water. So the germination process will release CO2 during I mean, the grain is going to release CO2. You will need, you know, a lot of thermal energy and HVAC just to cool down the grain and to aerate the grain, to keep it aerated. And also you will use high levels of energy consumption when it comes to kilning and roasting, you know, and kilning and roasting and caramelization, of course. And so so this is important to look at or discuss this, or have a better understanding from your masters how they are treating their wastewater, whether they have any wastewater plant treatment, how is their levels of you know, fuels and electricity consumption, and so that give you a better idea about which also you will need to have it when it comes to report, for example, the Beverage Industry Climate Initiative report. Obviously, here is our main mother. This is brewing and packaging. So all the inputs that are involved in the greenhouse gas emissions. So there are many, as you know, because brewing is a very complex process, operations. And but again, we're gonna go through all of them, but I presume you might know them, might know this, but what I really want to emphasize is, again, keep an eye on your packaging, how you are packaging your products, and also how is the packaging material production with your supplier, because this is really the key of all this talk, when it comes to greenhouse gas emissions and your logistics, your transportation of your products. But also we will talk later about how you can make also major contributions, reduction of this just with simple actions, actually, in your brewery. Then comes to the packaging. This is what I was talking. How this produce the bottles, how your cans are produced, your secondary packaging materials like your tray cardboards, your box tray cardboard boxes, your kegs, one-way kegs, even the stainless steel kegs. So so they call it primary packaging material, as you can see. Obviously, it's kegs, glass, aluminum cans, labels, crown caps, and your secondary ones, so your shrinking foil, crates and pallets. So these components also they're considered in this equation. So basically you need to go through every single input into the entire operations. And also is included your distribution and the storage of your product, which means, as you can read here, how your transportation, how they transport your ingredients, your products, and also from your own vehicles, even if you work at the office. So all this contributes your transportation. If you're using, I don't know, you're commuting or you're using bicycles, all this is into account to calculate or to evaluate your greenhouse gas emissions. So and also how your customers, or let's say in this case the retail market, or Systembolaget, with something that we don't know, which will be interesting to ask them if they ever have any evaluation about how much energy or how much gas emissions they're producing themselves, because they ask us, Systembolaget, to Swedish breweries about all details about this topic, but we don't know. We know little about them. So how much they are, what is the energy consumption for them to store the beers, the electricity used in their stores, the cooling systems, how they're dealing with the waste of packaging. So all that stuff. And also obviously not just with Systembolaget, or restaurants, bars, and beer festivals, and because all of them they're generating this, call it hotel load, as you can read on the slide. So which is obviously has this impact on the greenhouse gas emissions. So Systembolaget, of course, has a risk analysis for his suppliers. So they evaluate, as from cultivation and production, the country analysis where they are, importing their products, and there is some indicators, sustainability indicators according to the countries, you know, and they also request certificates, as you know. So as you can see, they're dealing with many of them, mostly with wine, and as you can read. Well, obviously the very known fair trade and fair for life and all these kinds of certifications, which are certain, I would say, yeah, they're related to this topic. And also they're looking at the cultivation and production. I don't know, I ignore, and if you please, if someone knows, but I don't know if they are being really in contact with malting companies. My assumption is not, but definitely are dealing with wine grape growers and, you know, wine producers. And but I think the most important point they're focused on for us is on the packaging. So again, packaging, and this is very related to the Beverage Industry Climate Initiative report, and obviously transport. So I will talk more in detail when it comes to this climate initiative. Okay, so I think, you know, I'm going too fast, but we continue. So at this point, there is any questions? No questions.
I have a quick one there.
Yes.
When you mentioned on the packaging side.
In the previous one?
Yes.
Okay.
About how that's a major impact.
Yes.
What do you think about the key kegs? Would you say they are good or bad for reducing the impact?
Yeah, that's a very good question, and it's always a tricky one. Of course, the supplier will tell you that this is the best choice, right? It's on one hand, you know, as you know, with one-way kegs, I mean, the whole idea is that besides of the flexibility, you know, of handling this key kegs or these one-way kegs, is they supposedly, I mean, that reduce the weight, and just by reducing the weight, as you know, there will be less greenhouse gas emissions, you know, because it's a less use of fuel, and so on that regard, and also there is less chemicals to use, because you need to pick up, you know, when there is a stainless steel kegs, you need to pick up your kegs, as you know, you need to CIP them, you need to clean them and for refilling and all that. So you avoid all those part of the processes. But on the other hand, I mean, you're dealing with polymers, you know, with plastic, you know. So the question here is like, where are they sourcing that plastic, you know? Because it's known. I mean, I cannot. I don't know the truth, but of where exactly they're sourcing. But it's known that many of the polymers are sourcing from Asia and China mostly. So it's, you need to say, okay, it is really environmental friendly. And the same goes, by the way, a bit out of the subject, with Systembolaget. Importing products is really sustainable, no matter if the brewery out there has sustainability certificates and whatever. So it's just need to think about how they're sourcing the raw material, you know, to produce your key kegs. Yeah, this is one thing. So and so this is something that I don't have the answer, but it's something interesting to ask to the supplier, you know, because we are just seeing the picture as a brewers, okay, just from our own needs, but we need to see the things, I mean, out of the, you know, from our little brewing picture, also to see how our suppliers are producing the products that we are consuming, you know, in our brewery. So that's, I don't know if you could answer your question, but
Okay, yeah, because I was thinking about that when I was in my latest internship here. We were discussing reusable key kegs, where you just replace the bag in it and not the actual keg.
Yes.
And I thought that was a good idea, but I don't know if it's worth it or not.
Well, you should try it. I mean, it's like, why not? I mean, it's, yeah. But it's, yeah. I mean, by the way, in which brewery are you talking about? Where are you?
Två feta grisar.
Okay.
In Gothenburg.
In Gothenburg. Okay, yeah. I mean, just absolutely. You should definitely discuss this further. You know, I will advise. I mean, there's many I would say situations. You know, things that we can do to get you know, to do better when it comes to the environment at the brewery. But as I say, already like 4 or 5 times just in this half an hour is the packaging. So guys, I highly advise you that look any single possibility. How can you reduce your waste of packaging, and how can you get more efficiency in everything when it comes to packaging? You know, also, you know, because again, you will make you a favor twice. You know, because it's not just about the environmental, also for your own production cost sake. You know, so something you need to rethink about. That I understand when it comes to craft breweries that we are when I say we, because also, you know, I'm also working at Nils Oscar, is that the how can I say, the gimmick part, you know, I mean, it's something that we need to have always have products that are attractive, a great story to tell. Storytelling is very important. And I know that most of the classic way how craft brewers do is just to come up with, you know, big visuals and labels, and, you know, well-known breweries they are dealing with that we don't need to mention even, because everybody knows them. It's like, you know, with very funky colors and attractive to the eye, which, because, you know, it's obviously a human condition. But the question here is like, do you really need to have such a big label, such a, you know, there are some breweries, maybe, you know, that they are even dealing with labels that you can peel off, and inside of the when you remove that label, there is inside extra information about the brewery or about the storytelling, which is very creative, it's really cool, but it's not really environmental friendly, you know. So it's not a criticism, it's just more to rethinking if how can you can you remain creative, because we must be creative in this market, but not overdoing, and not just generating waste just for the sake of look cool, you know. So this is my personal opinion. So but anyway, yeah, in short is yeah, please do, you know, try to looking for options with a kick X or even whatever is around, even with the secondary you know, packaging, you know, your shrink foil, or how you guys are dealing with the pallets, and how you're reusing the pallets, or you're repurposing the pallets and things like that, you know. Yeah. Okay.
Yep. All right. Thank you very much.
No, my pleasure. And so what else? So let's continue. Well, at least for another 5 minutes. So here we move to routines. You know, so there, of course, you can create as many you want. I mean, here are just an ideas. You know, something I collected, something that I experienced, but and some facts that I guess most of you already know. So when it comes to the less efficient breweries, I mean, our water consumption. You know, and let's face it, we consume a lot of water at the brewery, obviously because of production and mostly because of cleaning, obviously. So and the water is between 10 to 1. Of course, some brewers would claim, large breweries say, yeah, we consume just 3 liters, you know, or below 5 liters. That's excellent. But if we are talking about craft brewery, which I guess most of us were here, you know, in craft brewery, we are best case scenario, we are talking about 6 liters, but most of the brewers are between 8 to 10 liters, which is a lot. So this is something that this is very old news, but very little number of brewers that really take about it, you know. So and especially I would say here in Sweden, and it's again not criticized, but here is lots of water. And sometimes I saw brewers that take for granted just, you know, using water like crazy. And but when you look at another breweries that they are in the desert, or they have not much water, or the quality of water is not good, is when you're in these kind of situations, you start rethinking. So so it's good that even we have plenty of water here so far, but we need to really do big efforts in the water consumption with very simple things. Actually, you don't need to do huge investments on that. For example, as you can read here, the dry floor policy, you know, you can use more the squeegee. I know many brewers, they just take let's face it, they take just the water hose and they're just spreading the water all over the place, you know, just to get rid of their spent yeast and all the dry hops and all the waste we do and we dump on the floor or on the drain. So use more the squeegee, so simple. I know that brewers are always rushing because they're multitasking, but this tells you a lot about you and about your good practices and how professional you are and how conscious that you are for the environment, you know. So this is one thing. Another thing is like how to boost the efficiency of your transportation. Something also very, very important that how to deal just with your even if you're doing the transportation yourself or you're dealing with other companies, is also to discuss these kind of things, you know, like how to make the transportation easier. For example, with suppliers. Something that I practice is, which I advise you to do, is doing deals. I mean, so simple things like, okay, now, for example, that everybody's now start working now in your budget for next year. It's just also start contacting your suppliers and say, hey, you know, I estimate that they're going to consume this amount of raw materials for next year, you know, whatever, malt, hops, or additives, or yeast, you name it, and chemicals. And say, hey, if I place you, I don't know, just speaking loud, you know, 4 times a year, quarterly, you know, just give me, I will order this amount, you know, and you can give me like a, you know, free shipping. So you can save money, but at the same time also you're reducing the number of transportation, you know, which also has environmental implications. So these kinds of simple things, or also or when you guys gonna do the deliveries of your product, you know. So you trying to do deliveries when you are in off-peak, you know, and not in rushing hours, because and then you're gonna waste a lot of time, of course, but also you're gonna consume much more fuel, and of course this implies, of course, an environmental impact. And so maybe as you can hear me, it's like is that they are quite tied together, you know. When you are doing improvements on environmental impact of your brewery, reduce your environmental impact, at the same time also you're going to save money, you know. So, and again, you don't need to do such a nothing that you don't need to do such even investment, you know. It's more about organization, and of course the investment is your time, you know. You need to be more structured, and structure requires time. But that's what I can advise. I don't know how are we time now. I don't know yet, but so here, let's take this as a last slide. Here, something really important also I wanted to share with you guys, and I've been repeating this myself like a parrot in previous talks, is like the consumption of hops. Really, really, you need to rethink about it, you know, because I no promotion about myself, but also I have another job working on AAB as a global technical brewer, which means that I give technical support to many breweries around the world, and I go and visit them, and what I can see a constant every time I do is like the crazy amount of hops used for their products, because they're convinced that this is the way to go to have a great product and super hop aroma and so on, which is partially right, but it's partially wrong, you know. So it's so you really need to think, it's like how far is this really needed to go for such a high levels of hops to get a really quality product. Because sometimes we brewers, we trying to obviously want to please ourselves, you know, over a product, but at the end we are not, our customers, they are not really thinking if you add 12 or 14 grams per liter of hops, you know, they don't care. Only what they care is that the beer tastes good. and they can enjoy it. So it's something because the implication of this, as you can read here, is like the hops for 1 kilo hops. Look at all the amount of water is needed. Obviously, hop suppliers, if you ask to Jackie and Chief or to Charles Farham or them, they will say no, it's not true, but it is. You simply just go and talk to the farmers, you know. So and so if you really want to be serious when it comes to environment, you must work with your farmers, with both, well, in this case with your maltsters as well, you know. On the case you're dealing with farmers, if you're sourcing unmalted grains, but to see, I mean, really what is the real consumption of water they're having and how they're processing their products that we are using for our brewing. And to reduce your, another thing is, reduce your carbon footprint. We're going to talk about this at the end of this course, more in detail, how we quantify this, and the transition to 100% renewable energy, which this transition of 100%, yeah, in theory is fantastic, but in practice, as the situation as it's unfolding now in Europe, with the situation we know in Russia and NATO on this, is we should be a bit more conservative, because that will take a bit longer. And but we should not. That doesn't mean that we should discard it, but we need to also be realistic. But that's the intention, not how to use renewable energy. And the other thing is how we are contributing to the environment, because as you will see, there are some I consider very tricky, or sometimes I would say not reliable programs, as they call it, carbon offset programs. Probably you already know about them. So basically it's like you are contributing financially how to plant 1 million of native trees, you know, for example, brewdog within the Scottish Highlands. And this is very questionable, because there are already, you know, investigations, research that carbon offset programs, it doesn't make any difference for the real greenhouse gas emissions. So to me, it's kind of lazy way of how to deal with this subject. So the real way to do it is to really do real efforts within your brewery, and not just by giving money away for this kind of programs, you know. So that was the real way how you're gonna have a more significant and real contribution to have a better world, you know. So yeah, do you have any questions now, or should we want me? I can continue. How you feel?
Maybe we can take a quick break.
Okay, perfect. Okay, so we say in 10 minutes. Is okay for you guys?
Yes, we start back at 10.
At 10, perfect. We do that.
All right.
All right.
Yes. Hello.
Great. Okay, perfect. Let's continue. Just how can I move this? Can I leave this? Sorry, just a second. Sorry, a second. Sorry. Okay. Okay, so this is the another tip talking about circular economy. So this is, well, just examples that some brewers, what kind of approaches they've been doing. And for example, this Mountain Tap Brewery. This is something might sound fun. When you read it, it might look funny for you guys, but it's like when they say they brew beer, they use the Spain grains, they give it to the farmers, they feed the pigs, and they purchase the pork. So, and this is like a real true circular economy. Now, based on this idea, I've also been sharing this in the past, you know, how you guys can do it here in Sweden, the same approach, but even more effectively by using for example, enzymes, okay, in the brew house. How can you deal with higher levels of unmalted cereals? Even you can go to 100% unmalted cereals with no use of malt to help the farmers, your farmers around the corner, and process that cereals, brew it, those unmalted cereals, and do the same as Mountain Tap Brewery to ask the farmer to collect the spent grains, feed their cattle, and you purchase the meat, you know, pork or whatever it is, and use it for your tap rooms. That will be like a true circular economy, you know. And so this is one example. There is also Alaskan Brewing Company. They're using, you know, a beer-powered system, which basically they burn spent grains, and they're using, you know, sequentially, you know, the same, the further spent grains to fuel the next batch, and so on and so on. Which is not just Alaskan Brewing. Many other breweries, they do that, you know. And there is one also interesting one that they did it, I think, 2 or 3 years ago. Bryghusfinn, in collaboration with Lund University. I guess many of you might know about this case, that they're dealing with a greenhouse. They grow hops in a greenhouse, and which also obviously this helps to reduce, you know, the climate, greenhouse gas emissions, and you know, and everything else. So so here the key is that that you guys join forces with universities to do this kind of projects, because you need each other, you know. So we have the setup, but we don't have the knowledge, and we don't have the instrumentation that universities have or another research centers. And you can create something not just for the sake of creating knowledge, but also to truly optimize your costs, obviously, but also to have a, you know, reduce the environmental impact you're having these days. And yeah, so the keywords are, you know, get creative and collaboration, you know. And something I learned is that, you know, ask never hurts. So yeah, and that would be interesting. Of course, you can do this individually, or you can also do it through the brewer associations, or just with your brewery friends, you know. So it's not just one brewery, but many. So there are many possibilities. So other subject to talk about, which is, I know it's kind of boring for many people, but it's very important. Actually, it's one of the most important business decisions to make for breweries is the site, you know, the location. This is super, super important. So here, as you know, there are different type of properties, and the ones, so we can go through them, which is the greenfield, you know, that you construct your facilities, you know, in ground up, just from scratch. And brownfield, the same, but the brownfield basically areas that they have, you know, a history of landfill contamination. So mostly landfills. They're the less expensive and actually the most advisable. You know, actually they are, as you may know, is in many countries they're using now landfills, and they build, you know, new fancy areas, or, you know, offices or industrial areas, and because it's cheaper, and yeah, and they revamp the whole area, and then you revamp the whole economy of the area. So this is a great option if it's possible. And also there is rehabilitations, obviously, that you repurpose the structure of existing buildings, and historical properties. These ones is good for your storytelling, but I don't think technically is the best way to go. But these are basically the 4. Now, when it comes to environmental impact, I think it's advisable is to consider the brownfield site if possible. And the other things you also need to consider when you're choosing your location and your facilities is your day lighting, of course, especially here in Sweden, your HVAC, your ventilation system, you know, and the possibility to use solar and wind energy. And besides of that, your electrical installation and what kind of considerations you need to have. You know, if you're using LED light, and also, well, in this case, they are not doing. This is more, as you can see on the bottom of the slide. Even I took it from a source. Even it's older, and it's still actual these days. I mean, it's a current document for the Brewer Association. It's a great document. So it goes everything in detail. So I highly advise you to look at it and to go through it. And it's a really good one. So still many of these things still, you know, quite, actual these days, you know. And for example, but they say also advice to space for rainwater collection tanks. And I don't think many people do these things here. I don't know anyone, but it's something information for you to know. And how to install more sustainable landscaping and green space, especially for those actually big breweries that they're having like big gardens and things like that. So another thing is your transportation and traffic that I say earlier. So trying to avoid using your own vehicles, you know, especially when you're living, you know, far away from your brewery, trying to use, you know, public transport, bicycle if it's possible, walking, you know. So other thing is to consider not to over design your parking areas, because that generate the heat island effect, as you can see. And you can read is which that will generate absorb and re-emit the sun's heat, you know, and as we know in all urbanized or city areas is a problem. So and focus again on your traffic when you are delivering, supplying, or, you know, your own delivery, also your suppliers, you know, when they're coming to deliver, you know, all their goods to your brewery. So it's important. And other, you know, kind of rule of thumb, when you calculate your power requirements, you're advised to be like 7 watts per square meter. And also you consider apply all this knowledge, all this information, so not just at your brewery, but also in your tap rooms, and actually pay extra attention. And especially you guys who might have already a tap room or they are about to open a tap room, pay a lot of attention on the, not just on these things, on the locations, but also everything related on the operations of the tap room. Because I can tell you from my own experience on the tap room we have and the others bars we're dealing with is they generate a lot of waste. And they're very little knowledge, I would say, or consciousness for the environmental impact in restaurants and bars. So if they do things, it's just they're following just local legislations, but they're little self-initiative of doing extra efforts on reducing the environmental impact. You know. So it's not just the brewery, but your tap rooms as well. Another considerations when you are, you know, building or, you know, or getting your facilities when open a brewery is your insulation. This is something very important. We're not talking in detail. This is also when you're running your brewery, is when it comes to insulation, the air sealing, any type of leak. You know, you're gonna have energy leak, air leaks, all this, they're gonna will have an impact on the environment, but also will have a huge impact on your pocket. So it's something you need to keep an eye. So, well, I don't need to repeat what is written here, but just to give you some info is important. The orientation of the building is west direction, ideally. And yeah, I would say the insulation is something that really you need to keep an eye. And your HVAC, your heating, ventilation, and air conditioning. So we're going to talk some more about it. Other thing is obviously one of the main sources of energy consumption at the brewery is your boilers. So trying to use, in the case that you have the possibility to deal with low pressure hot water boilers. They're very efficient, as you can read. Also, if you're dealing with steam generators, look, most of them already have it, but in the case that you have old ones, relative old ones, try make sure that your system, your steam generator, has a condensate return system, because you're going to save a lot of energy and water and feed water. When it comes to insulation, this is like a rule of thumb. So any equipment with a surface temperature greater than 50, it must be insulated. Okay. Another thing also to keep an eye on your water consumption is, obviously, that sounds like obvious, but many brewers do not do it, is the use of flow meters. So you can use, the most sophisticated flow meter you like, but you can always use just like, volume water meters, that you can get in a DIY store. So and so you keep an eye on how much water you are spending, not just for your batch, but also for your cleaning or for extra rinsing or just to transfer product from one vessel to another vessel. So you have better understanding about your total water consumption. Also, when it comes to boilers, so there is another important that you look at is with the possibility to, if you're going to buy this kind of systems, to have a flue gas or exhaust gas economizers. So it's a heater exchanger, which I will tell you more in detail, how it looks like, and I mean basically the principle of the operation. So as well, purchase mash tuns, kettles, and hot liquor tanks has to be insulated. I know that many craft brewers practice, as here in Sweden, buying vessels from dairy industry. I do not advise do that, just for the sake of saving money. So because you need to think that if you want to run your brewery for real, seriously, it's gonna be for many, many years. So it's better that it's not just to optimize your costs, but also think in the long term, for your own sake of your own economy, and also for the environmental impact. So, and there is now these days, as we know, unfortunately, we are facing challenging times in the brewing industry. So, but you can find a wide spectrum of equipment of different, price range. So there's a lot of stuff out there that you can afford, and you can use it to have a better process to have a better brewery in general. Yeah. And the other thing is, this is the last point: install stack heat recovery equipment to reduce heat. Yeah, that's true. It's also very useful, but honestly, this kind of situation requires a significant investment, And of course, you can always go to German brewery manufacturers like, Kaspar Schulz, Braukon, GEA, Hupman, all those guys. And they have many solutions, very sophisticated solutions. They are great solutions, but they're very expensive. So of course, you're paying what you're getting. But also there's another systems as well in the market. But anyway, there are systems that requires at least 5 years ROI, return of investment. So this is, I would say, for breweries that at least they're producing above 1 million liters a year, so in my opinion. Another considerations is your pumping systems. So sizing of pumps, of course, you might hear this many times. Okay, as everything, no, you need to have the right sizing for any part of any operation of, unitary operations. But yeah, it's important that you size your pumps. This is very important, and especially I would say if you need to compromise, I advise to oversize the pump rather to undersize it. You know, the capacity of your pump. So, and I would say this as a general rule. For example, for beer filtration, for microfiltration. For instance, if you are dealing with a centrifuge and then you want to have a crystal clear beer, and you will require, very likely, because it's a luxury having it conditioning for many days, a microfiltration skid, you know, unit downstream, so after the centrifuge. And so it's ideally that you have a, you know, slightly oversized for the sake of, let's say, filters, sheet filters, so these filters, cartridge filters, but they're expensive. So what you want is to extend the lifespan as much as you can. So the idea is always keep that in mind, and it's not just for beer filtration in general. It's like any operations that requires, you know, contact, contact time, and you know, and surfaces. The greater the contact area you got, the longer you're gonna preserve the medium that you are dealing with. In this case, the filters. So the more the more the number of filters you have, or the filtration area you have, according to the total volume of your batch, the longer you're gonna preserve your filters. Because what is very common is that I see in many breweries is that they normally undersized their filtration capacity. So they are all the time rechanging, replacing the filters on regular basis, and of course it generates lots of money. So this is one example. So, but always think about the greater the contact area, the longer you preserve the medium you're dealing with, or you're gonna save money. You're gonna extend the lifespan of filters or whatever you're dealing with. Which makes sense, right? Another thing is to avoid 90 angles when in piping in general. I would say for whatever fluid means it's not just liquid, not just beer, but also air, you know, steam. So avoid those 90 angles, because that will generate, in the case of steam, condensate. When air, the same with the air. I mean, there will be pockets, you know, that in those angles, and that will reduce the efficiency of the process, you know. So in the case of the steam, you're going to reduce the heat capacity, and the same with the air. There will be condensate. There will be a lot of energy losses, basically. So then when it comes to refrigeration, try to, can be with the largest electrical load at the brewery. Actually, it is. This is the main consumption. Cooling is the main the major electrical consumption in the entire brewery, for sure. So also it's advisable for that reason to deal with the pumps, the same with the pumps, to use variable speed drives, you know, where you can control basically the speed of your pump, you know, the flow rates. So for your chillers, your compressors, your pumps, your motors, it's additional cost, but you're really going to save a lot of energy, and I think it's really worth doing the investment. What else? Of course, don't locate your cooling system, your chillers. You know, all the exhaust air must be vented outside. You know, that's important. I guess this is like, I guess even by the law, if I'm not wrong. And then when it comes to compressed air systems, actually the compression, that's very interesting. Air compressors are the less efficient utility in the brewery. So you can read here, it's like from 8 horsepower used in the compressor, the only one is just usable. So it's very it's not the most efficient system at the brewery. So it's very important the way how you're using it. Of course, this will vary, depends on the technology and the supplier, but in general, there's a lot of energy waste, or losses with the use of with their compressors. So here the key is that trying to be smart. How are you using your air, your utilities, your air in general? How to don't overdo with your consumption of air, basically. And again, here you can have pressure drops depending also on the angle of your pipings, trying to minimize these angles, 30, 45, and 90 degrees angles, whatever possible. Also, you can use buffer tanks also to reduce reduce the impact of pressure drops in the system. And something also we'll talk later about, very useful, trying to implement in your practices in your brewery to looking at air leak detections with devices. We will talk more about it. And then heat recovery, of course, wherever you can, from your heater exchanger at the brew house, your CIP stations, your work cooling, whatever possible, you can save recovery heat. Lighting systems, that's like obviously trying to use more efficient lighting, using LED light, daylight, of course, even better. Trying to reevaluate your HVAC system. That means your heating, ventilation, and air conditioning system. So consider multiple stage heatings. For instance, the most obvious one at the brew house. I mean, don't cool your wort just exclusively with your chiller. Trying to use also the water from the your main water production water source that you can reuse for the subsequent batches, for the future batches, and so you don't consume so much energy from the chiller. Also use, I guess also is by the law these days, if I'm not wrong, use round ducts, air ducts instead of square ducts. So that's because also this helps a lot of flowing the air, and then obviously that relates to energy. And yeah, and minimize the use of fiberglass. I mean, just many things here. They are like kind of common sense, but as you know, sometimes the common sense is the less common. So is to avoid placing and cooling equipment in the direct sunlight. And I told you this because I know that sounds obvious, but I saw many breweries doing that, having the cooling systems just direct to sunlight. So avoid that. Now, when it comes to water usage, which of course is one of the main topics also to talk about, is first we need to map out, what is the entire amount of water consumption we are dealing with, because the obvious choice is that we just go straight just to the water bill, but it's not just your water bill. You need also to consider other things involved in this, which also the cost of the energy, and the chemicals needed to process your water. I mean, your wastewater, for example, and also the labor and cost, I mean, your manpower, and even consider the cost in the case that when you need to send samples for analysis, So it's not just exclusively water bills. Then something that people don't think about it when it comes to this, when it comes to how to optimize your water, you start thinking about many other things about leaking and so on, cleaning and so on, but something that you really need to think of is how to increase your brewhouse yield or your beer yield in general, you know, because obviously it's just our beer losses, but that implies more consumption of water as well, okay? So because that basically is product that is just wasted, but also you need also for cleaning and everything else. So everything, the better your brewhouse yield, of course you optimize your cost, and also it has a less environmental impact. So it's a bit selfish or with a sense of arrogance when it comes craft brewers and to say, no, I don't care about my brewhouse yield because what I care is about my beer, how good it tastes. And my recipe is like this way, and that's it. So that's not the right way to think because of this implication, you know. So it's important that trying to do your best how to increase your brewhouse yield, and using enzymes or other means is totally valid, you know. But that's a main problem, and especially with the Spain grains, you know, as you know. So because you need to consider that in the case that you are giving different use to your Spain grains, for example, for combustion, and it requires energy just to dewater your Spain grain. So this is not really environmental friendly, and at the end you have to pay for this, you know, to the companies you're dealing with. So or yourself, you know, in the case which I don't think. But anyway, there's additional expenses. Now, when it comes to brewhouse, I mean, very simple things so you can improve your environmental impact and your pocket is install just, you know, water meters, you know, that you can get in the DIY stores. They are quite accessible in price, and you can do it yourself or ask any welder. They can just install it for you in your water lines. Also trying to store the surplus water into the next brew. The trough, you can reuse the trough if you want. They will not have any impacts on your production. Of course, depends on the amount, like anything else, but also trying to use it. Don't mix, this is very important, don't mix residual water to trough with surplus of yeast, you know, especially because I'm seeing some brewers, they put everything together with the yeast and the Spain grains and the trough, and that will create very quickly increase of BOD, which we're going to talk about later, about what BOD means, you know, and the implications of the BOD into the environment. So trying to use dry methods. I guess most of you do, you know, using rakes is to remove your Spain grains. Try to use the less water possible. Trying to, also very important, maintenance of your equipment, and especially on heater exchangers. And I'm not just talking about work coolers. I'm talking heater exchangers in general, also for your CIP stations and even your packaging lines. That's always important. You keep an eye that there are no leaks, you know, of the coolant or whatever you're dealing with, you know, even with the steam, because that will cause an excess of water flow, you know, obviously, and especially with your wort chiller. So it's important you keep an eye on the integrity of, let's say, of the gaskets or the seals of your heater exchanger. What else? Of course, keep isolated your hot water tanks and prevent hot liquor tank overflows just by having a volume meter, just simple like that. When it comes to fermentation vessels, also prevent obviously overflow, that's obvious, but also something important is if you're dealing with open fermenters, which is the use of open fermenters is very interesting. I mean, like quality wise, if you want to, it's known that if you want to promote more esters in your beers, this is very well known for nearly centuries, that using open vessels, for example, Bavarian brewers, they deal with open fermenters when they are brewing their famous Hefeweizens or Weissbier. And it's true, you can get a better product, you know, because there are many factors of how to promote or to repress the formation of esters, but what is known is that hydrostatic pressure is also one main factor of repressing the formation of esters. So, which is what happens also in closed systems like CCTs, okay, and of course on the height, you know, so and of the vessel, which obviously CCTs are higher they're taller than open fermenters. Open fermenters normally they're like more like a swimming pool, you know, they're more square. The configurations are more squarish, or yeah, also they're cylinders as well. But so open fermenters. The problem with open fermenters, as you can read, is they require more cleaning because it's more manually, and that also has an impact on the water consumption. Also, the detergent sprays, for example, sanitizers, as you know, is well known by home brewers and craft brewers using sanitizers which are propionic acid based. Which you don't need to rinse them. That's a nice way also to reduce to save water and to keep your process safe, you know, of contamination. So yeah, another thing is I didn't mention here on this slide, but I just remember now is that when you guys are conditioning your beer or maturing your beer, you know, or cold crushing as they call it now, is that is to do tests with yourself, because there is no rule of thumb. Don't follow recipes just because they're reported by your on out there, or because you've been using this for years, all your years, the same recipe. Trying to always to improve your recipes, or your beer recipes. For example, when it comes to cold conditioning or maturing, it's like really evaluate if you need to go so low in temperature, because I noticed that many brewers, they go like 0 degrees Celsius, and some others up to 2 degrees Celsius, and I can prove you that there are some you can clarify your beer to have a good conditioning even at temperatures of 4 degrees Celsius, even with ales at 8 degrees Celsius, you know. And also think that it's not just about beer clarification when it comes to conditioning, okay? It's also is about you need to think that fermentation and or flavor development is not just related to biochemical reactions. It's not just produced by the yeast. Simultaneously, also there are chemical reactions happening. So, and of course, chemical reactions are triggered or repressed according to the fermentation temperature. So you need to, knowing this, you need to make you need to have a balance, you know, in terms of, to establish the right temperature, I want to say, of your condition, or your beer conditioning. So in short, just evaluate your conditioning maybe a warmer temperature, because by doing that, you're going to make a favor to the quality of your product, but at the same time, you're going to save money. So you're going to do a favor to your pocket, and also you will have, you will do something better for the environment. Okay. What else? Something. Yeast disposal. Of course, this is a main problem for all of us. Yeah, including me. So how we're dealing with our spent yeast. Let's face it, most of us, dispose it to the drain. Sometimes we can spare it in the vessels and then dispose it in another time, but sometimes it doesn't happen, especially during the peak, productions, and so it's something we have to work harder on that. And I'd say, when I say we, also I know, because I've visited many Swedish breweries and they do the same, and they don't know much about it. They just flow with a lot of water. But the implication is the BOD levels. Depends on the size of the brewery. I know that the small brewers, they are not called by the authorities to they don't get red flags from the authorities to say you need to do something about your BOD because of the size of the brewery. But it doesn't mean that you don't need to do something about it. So, and the problem is for the water municipality plants is an issue to do it. They have the capacity, by the way. They have actually overcapacity most of the times, but it's expensive just to treat the wastewater to reduce the BOD levels. So it's important that we have to do bigger efforts on this. And so another thing is the use, as I mentioned earlier, the use of centrifuge, to how to recover more beer. So it's not just about optimize your process. In the past, people were saying, I remember, like, I don't know, 15 years ago, that using the centrifuge was a bad practices because you want to reduce the quality of your beer, but that's not true. So it's in the large breweries, the use of the centrifuge has been used for beer recovery. That's it. But of course, now craft brewers are using it for just as a general for beer clarification. So just it's important that point. What else? Well, I think this is things I already said. Vacuum pumps. That's when you need especially when you're dealing with sealed water. Cooling towers. So it's important that you reuse the water because there's a lot of water waste when you're using with vacuum pumps, as you know. So trying to rethink how to repurpose this, not just go down to the drain. Maybe you can reuse it for other purposes, for cleaning or something else, or send it back for, I don't know, for a water tank. I don't know. So it depends on the configuration of your brewery. When it comes to packaging, trying to, in the case of you have a standard steel belts. You can always use dry lubricant systems, and otherwise you can replace the steel belts for plastic belts. I think these days most of the craft breweries are dealing with plastic belts, but that will help you to avoid the waste of water that you need for to lubricate the bottling lines. So that's a good one, and there are many dry lubricant systems out there, and also the chemicals. They are relatively expensive, the lubricants, but you need little amount. So honestly, it's not a really big impact on your cost. So it's minor. Oh, by the way, okay. Something else is about to have a better understanding about our cans, aluminum cans. So why they are so popular these days when it comes to environmental impact, as we mentioned earlier, because of the weight and also the recycling life that this packaging format has. So as you can read here, it's like 75% of the aluminum ever produced is still in use today. Well, this is what Ball is reporting. So Ball is also reporting that the current aluminum use in Europe, European Union, is 60%. One can-to-can life cycle is 60 days. Okay, so here is the key. So recycling of aluminum is less energy demanding than to create a primary aluminum can from scratch. Now, Here's the debate. So you need bauxite, okay, which is an inorganic compound, and which is found, as you can see on the right-hand side. The main sources in the world here, by far, is Australia and China. Also, as you can see, Brazil, India, those as well. But the question is just to explode those mines from those places and to process there all the aluminum and bring it over to places like here. That's what needs to be considered, okay? It's not the same case as glass. So no matter the information you are reading above on this slide, so it's something needs to also be evaluated. And so as you can see, the process of aluminum, as you can see on the bottom of the slide, is so you extract the bauxite, you produce the alumina, and then you make making the actual aluminum metal in layers. And so yeah, but the point here I just wanted to raise is the extraction of bauxite, so how environmental friendly is. And this goes the same with lithium, with these energy cars, So we need to really see the whole picture and not just we here living in Europe. We need to think about the others out there and the implications that this has just to extract these inorganic compounds. Another thing is the CIP systems. So of course, try to CIP. If you cannot CIP your system, try to use high pressure hose. I think also you can get this anywhere, to your suppliers, and your chemical suppliers they have also these kind of items, or in your DIY stores. Another thing is the pH. I mean, all this, I guess, is all news for you guys, but it's important to mention is the use of pH or conductivity meters when you are determining the concentration of your chemicals in your CIP stations. That's also, you're going to save a lot of chemicals, and of course money, and also and environmental impact. It's going to be less environmental impact. When it comes to cask and keg washing, minimize. This is also in general, I would say, CIP. Guys, trying to increase more your temperature and reduce your concentration of detergent. But you might say, okay, but if I increase the temperature, I'm going to have a major energy consumption. That's true. But also in the long run, you will realize that just to get rid of the detergent, the water consumption, and the use of the chemical itself, just to bring the chemical to your place and everything, at the end is more efficient, increasing the temperature of your CIP process than using high levels of concentration. Of course, this is important you discuss with your chemical supplier, because also depends on the nature of your chemical. As you know, something important, if the case you guys know, some of you don't know. So when you are dealing with your chemicals, your CIP chemicals, your supplier should provide you a curve that will give you the information in terms of the concentration according to the conductivity meter, conductivity, okay? So, and also conductivity, temperature, and concentration. So then you will know, it's a curve that you will know what is the ideal temperature to deal with in your process. And another thing is the glass bottles and pasteurizers. Yeah, again, use water meters. And again, we're going to talk about this more in detail, the detect water leaks. This is the simplest thing you can do at your brewery, detect water leaks. And we know, all of us, we know that we have water leaks at the brewery, and we do little about it. We just leave it because we have no time. Sometimes it will not, but it will not solve by itself. So there is a lot of water leakage here and there. So just by doing these little repairs, you want to save lots of water, more than you think. Steam generation, again, trying to repair leaks, isolate as we talked about earlier. And when it comes to the tap room, again, is just to install grease traps, and because you're dealing with, frying stuff mainly, repair leaks, no matter even in the toilets, So that's also very important. As you notice in the restrooms, there are another type of, these days there are many options. You can deal with low flow faucets that they give you around 6 liters per minute. Toilets, the same. There are some very efficient toilets these days, and urinals. And your landscaping, So here is just an example from the Brewer Association, use Xeriscape, but it's basically using desertic vegetation like cactus. Of course, it's not the case here in Sweden, but trying to think about it. I mean, because you have gardens around. I mean, how you are dealing with your gardens, and how is your landscape in general around your brewery. So I think we can have a break if I'm not wrong. So do you have any questions? No questions? Okay.
Not right now, no.
Okay, good. So we can have another 10 minutes break. Is okay? All right. So let's continue. Let's talk now about wastewater. So it's a very important subject. Here, as you can see on the slide, first we need to know what is the composition of types of wastewater first. So then you have the production wastewater, which is the way we do when we're brewing, the industrial water or cooling water that we're using for cooling systems, and the sanitary wastewater, and the stormwater, Here the important thing is to know the sources and the composition of the wastewater. So the composition is beer, obviously, that's the main one. Span yeast, also some span grains, as we talked earlier. Additives, Kieselguhr glue from your beer labels, rinsing water with disinfectants, and or sanitizers, and your cooling water. The constituents of the biochemical compounds, which are mainly present there, and inorganics, are depletion materials, as they call it. There could be uric acid and glucose, which are actually the main and the nutrients that they are used by the microorganisms, which is what generate all these ugly smells, but also generate heat, and is actually what contributors of the global warming, if you like, So which is the main harm caused by the wastewater. Also, there is some polluting agents, which are heavy metals, synthetic organic compounds. Things also comes from lubricants, many things that they're going to be absorbed during the packaging process, and some substances, oils, salts, and clay. So that's basically all the constituents of the wastewater. Now, this is an important concept that you need to have clear. Is the BOD and the COD. So the BOD, as you can read, is the biochemical oxygen demand, which basically is the oxygen that the microorganisms that they are residing in the wastewater will need to break down organic material, okay? So, which all these constituents that I mentioned earlier. And the COD is the amount of oxygen that that chemically, through oxidation, gonna break down organic material. So there are two different. So basically, that's why one biochemical done by microorganisms, and the chemical done by chemical oxidation. Okay, so obviously the most common or the main one contributor to this waste is the BOD. Okay, and the other concepts you need to know is the total suspended solids, which is mostly spent grains, centrifuge, so spent yeast that they are found in the wastewater. Obviously, the pH that you're familiar with, and another important specification is the total nitrogen, the on nitrate and NO3, and the total phosphorus, the phosphates, which in our process there are high levels of phosphates in the malt, in the spent grains. So that's why, and this will lead to formation of phosphoric acid, which also is quite corrosive. And in the case of the total nitrogen, the nitrates, also they will generate ammonia, and from the ammonia they're gonna produce nitrous oxide, which is one of the main contributors of the greenhouse gas effect emissions, the gas emissions, and this is actually a gas, and obviously it has a big contribution to the global warming. So you can see on the diagram on the left-hand side, so you have the insoluble constituents and the soluble constituents. So you have those insoluble ones. They are the ones who are suitable, floating, and suspended. These ones which I can consider as the total suspended solids, okay? And then you have the soluble ones. You have the organic ones, which are measuring biologically, which are related to the BOD, and these ones are going to be treated in the wastewater treatment plants through aerobic plants or anaerobic plants. I will tell you more in detail in the next slides. And the inorganic ones that I mentioned, salts, for example, are inorganic. So, and those can be treated physical, chemical, physical treatments, which related to pH as well, so dealing with caustics and acids, basically. And so here's just a comparison that I wanted to share with you, which is the total amount of BOD. By the way, BOD, I don't know if I mentioned it here. Yes. Sorry, I'm going back. The BOD, when you will see they say BOD 5, means that is the total organic content, and the amount of oxygen required to break down the organic material over a period of 5 days. Okay. When you see BOD 7, it's obviously they're talking about the same concept, but over a period of 7 days. Normally, they report in any lab or wastewater treatment plants, they report in BOD 5. Okay. So here the ratio between the COD and BOD is just in a communal wastewater around 2, okay? So at the city. But in the case of the breweries, we generate major levels of BOD, as you can see. So instead of 300 milligrams per liter, we got up to 1,600 or even more, We can go even up to 4,000 milligrams, So the ratio, the COD and BOD is much higher. So we are talking about, well, the ratio is 1.5, but also the concentrations are much higher. So here is one of the main weaknesses or major impacts we are doing in the brewery to the environment is the wastewater. So how can we treat the wastewater? So first, and I guess most of you know, the first treatment to your wastewater is the pH neutralization. So here, according to the Brewer Association, say that the wastewater gravitates towards higher pH because of the use of caustic in our cleaning procedures, our CIP. and lower pH when you're dumping yeast, basically. So, honestly, here, what I can say in general in the craft breweries in Sweden, most of the cases you're facing a lower pH in your wastewater. And then for that, to make this neutralization, pH neutralization, you require holding tanks, or they call it also equalizer tanks. So, which also to equalize the temperature or the pH or both. So this is, I don't know how it depends, I guess, on the municipalities here in Sweden. But for example, in our case, we have our holding tank equalizer. For a brewery that produce with a capacity to produce up to 3 million liters a year, you know, we are far from that, but this for this type of size of brewery. Now, solids removal, you also need it. The suspended solids that I mentioned earlier. So you will have, you know, remove glass, labels, all that waste, you know, also needs to be separated from the water, obviously, before to be biologically treated. Here you can see on the right-hand side just a diagram, illustration, how they look like. These equalizers or holding tanks, just to remove the suspended solids or these solids in general. And after that, once you remove the solids and you adjust the pH of your water, you need to treat it biologically. So as I mentioned earlier, there are two types of systems, so they can be even combined. So there are the aerobic ones, which are just aerating, you're supplying air, and the anaerobic ones that they're not supplying air, which are a bit more complex, and I will show you why. So just to let you know that the municipalities in Sweden, they just deal with aerobic systems only, okay? So, aerobic treatment, it will involve the presence of aerobic microorganisms, of course, mainly bacteria, while the anaerobic can be mixed culture of microorganisms. But here the point is that the anaerobic plants are capable to produce biogas, okay, as you can read. So, and that, of course, can be used for different purposes. Obviously, that's more complex system. That you need to have more variables to deal with because it's more sensitive how to deal with these cultures. You need to have a greater contact area, and also you need to have a vessel to collect the biogas produced. So it's more complex system, in short. So here I just wanted to give you some numbers about, you know, the smallest aerobic systems. You can see the figures. So they're equivalent for breweries that produce 20,000 to 30,000 hectoliters per year of production, which is basically just here in Sweden, very 3 breweries mainly, craft breweries in Sweden, and that goes basically for the large breweries, you know, like Spendrups and Carlsberg and Åbro, you know. So this is those systems, no matter aerobic and anaerobic, they're very expensive. They're because they're quite complex and also require footprints and are not just installation. Obviously, it's how to run the systems. It's also demanding. So you need to have also manpower. You need to have a team that can be just working on that full time. So so what is the problem when it comes to these systems? I mean, wastewater treatment is a long retention time, especially in the holding tank, in the equalizer, and that will increase the acidity because, you know, it has also can produce, as I mentioned earlier, phosphoric acid and carbonic acid, so it can be also corrosive. But the main problem also is the smell, the odors problems. So which also needs to be regulated, you know. So there are many implications here by running a wastewater treatment. So for you guys, I mean, obviously the important thing is to be in close communication with your water municipality and authorities, and to establish what is the BOD, maximum BOD level that you can, have in your wastewater, and at which point of according to your volume production, the production volume, sorry, is what is when is the time for you guys to have to adjust the pH of your wastewater, and they might ask you or demand you to have a holding tank. So yeah. Then comes here I just want to show you some process diagrams about comparing the aerobic and anaerobic treatment. So sorry guys, I just got a call now from the DHL. I will need just 10 minutes of your time, which I compensate you, of course. So I will need to have a little break.
Yeah, I'll just pause for a bit then.
Okay, thank you very much. Okay, guys. So, as I was mentioned earlier, just if you can see these diagrams, just to see the differences between aerobics and anaerobic plants. So, as you can see, you just need the holding tank. You have both they have buffers. So, in principle, at the beginning, both are the same. Here, the only difference is the aerobic plant. They have, multiple vessels that you keep aerating all the time, and then you just pretty much screen out the slurry. So they're much simpler. As I mentioned, this is the systems that all Swedish water municipality water plants have, and this is the anaerobic one. So very few have these kind of systems. Breweries actually, which you have, they have the same. Just to remove the total suspended solids, and then you have the acidification stage, and where you pretty much are, here's where the propagation of basically the metabolism of all the wastewater constituents are metabolized by the microflora, which is going to be producing, besides biomass, is going to produce methane, as you can read here, So this is basically the whole story. So obviously you need to control, as I mentioned earlier, it's more complex because you need to control. pH is super important. They're very sensitive with the change of pH of this microflora, and also the capture of the gas, or the biogas. So it's more complex. So that's why very few they have it, even though they're still available for breweries, and actually for craft breweries, I will give you more numbers because actually I request from Nils Oskar some quotations from different manufacturers, and there's one like in Australia which are quite good, but again they're very expensive, to the investment and to run them. So just to give you here some facts. As I mentioned earlier, the water to beer ratio. So we are wasting, we're about from 4 to 10 liters of water, per liter of beer. If you guys are doing more than 10, something is very wrong, So it's you should be around 6 to 8, to just to do the things. Ideally, as for craft breweries, they should go 5, 6, 6 sounds like it's a decent number. So if you are guys capable to have a water consumption of 6, you're doing quite well. At craft brewer conditions, of course. Basically, here the important thing just to mention is just the total amount of BOD. You can go for 600 to 5,000. Honestly, I mean, if you are dumping the yeast on regular, as a common practice, you might be around minimum, 3,000 ppm, so milligrams per liter of BOD. So chemical oxygen demand, it depends on, there is no really depends how you're running your brewery, to be honest. pH, yeah. So normally, if you're dumping your yeast, you are below 4 or 4.1, but normally you might be about 3.8. And if in the case that you're dumping the yeast, and you have runs of you're dealing with high concentration of chemicals, and then also your pH gonna be above 8. So, but that I would say is a rare case. This more happen in large breweries, I would say, or craft breweries of really, craft brewery term is a very misguiding term, I would say. So I prefer to call it in the old-fashioned, like microbreweries, regional breweries, and macro breweries or large breweries. So I would say regional breweries and macro breweries, they are facing more the issue of higher pH in their wastewater rather the way around. And craft breweries more lower pH because the dumping yeast. So something that I guess you guys who are working in in bigger craft breweries or regional breweries, you need to take samples. When you're sampling the wastewater, because it's so it changed the constituents and the pH very quickly. You need to sample like 24-hour samples, and there are machines doing that. There are instruments, which are owned by the water municipalities, the units, the municipality water units. So when you're doing this kind of approach, you can borrow this instrument from them. So of course you just keep in touch, and they will let you know how to run it and how you can sample it, because the sampling here is super important, like anything, but especially in this one, because they can give you the ground picture if you don't know how to sample the wastewater. And it needs to be once you sample it, then it needs to be analyzed immediately, because again, this fluctuation of pH is very quickly, and because the metabolism of the flora is running all the time. Another things, well, here I just wanted to mark this table pretty much give you all the picture about all the main areas of wastewater generated. But the key here is look at your spent grains. So it's very important that you trying to not go so high with your last runnings, obviously not too low, because and then you have implications on the quality of your beer because of the extraction of polyphenols and silicates and many others and phosphates, but also don't go so high. So don't keep attention on that. So because otherwise you will have big amounts of last runnings, which will contribute with a lot of BOD in your wastewater. And of course, your fermenters as well, you're dumping your yeast, obviously in your storage tanks, your BBTs, and your filtration or centrifuge system as well, So also the centrifuge, your settings of your centrifuge, So that's important. Now let's talk about the energy used in the breweries. So as I mentioned earlier, cooling, refrigeration is the largest electrical consumption at the brewery. Here the point is what we consume the most is obviously thermal energy, when dealing with our steam, for heating purposes, our electrical energy because of cooling, okay? And not cooling, but also for utilities for air compressor, that we need. So I didn't mention that earlier, but that's important. Don't use air for drying, bottles or something, because sometimes brewers do that. I've been doing this myself, So Once you want to have wet bottles and you want to, normally in the packaging, or wet cans, and you start using your air compressor, you just passing through the air. So it's like, yeah, you can do it, but just remember this: you are wasting a lot of energy by doing that. So what else can I mention here for you guys? Well, here just I think I mentioned pretty much everything. Yeah. Now, when it comes to this slide and the next slide, I think it's very important for you to keep in mind that how can you make big changes, or like really useful changes when it comes to sustainable practice, how to implement sustainable practice in your brewery. So first, again, repair any steam and air leaks. That's like number one, and water leaks, of course. So shut down all the equipment when you're not using it. Change the air filter, something that many people don't do. Also that, because otherwise also there will be a lot of energy waste there. Clean your exhaust fans, everything, give maintenance pretty much, or your HVAC. Also check your repairs. Here the key is basically is maintenance of HVACs, of your utilities, and leaks, all kind of leaks. So and there is a way, and simple ways how to do it, is because sometimes they're not so easy to detect. So you cannot only rely on your naked eye. I will show you more what kind of instruments you can use. This is about immediate cost, and actually those immediate costs from this slide, this is very simple to do, and you're gonna save lots of money, and that you don't even realize that you're wasting at your brewery right now. So there is another one, the other practices, they are, as they call, moderate cost. The paybacks are between 2 to 4 years. Is to deal with pumps, as I mentioned earlier, with variable speed drives. Obviously motion sensors, new insulation that we talk about, the insulation, it's not cheap, but also it's not like crazy expensive. So it's good that you keep an eye on that, or the insulation of your systems. And also to automated building energy. Well, more than the automated building is more to implement an energy management system. Okay, I want to talk about this after this topic of sustainable practices. Also replace your HVAC units that are older than 15 years. That I see in many breweries, that case. So keep an eye, how efficient your HVAC units are. Your maintenance of your boiling system, of your steam generators, or your boiler systems. So check how your condensate return is working. Also in the case that you have a gas, a flue economizers, if they're still running properly. So, but because I know that brewers, they don't do maintenance to their steam generators unless is very necessary, or they are under inspection by authorities, but otherwise they don't keep much attention to that. But you can really save a lot of money on together with the leaks. Yeah. And another major investments, is just to implement, for example, the flue stack or energy recovery systems, basically at the brew house. So there are many out there, but the state of the arts are pretty much German systems, and those basically what they do is just capture the vapors during boiling or mashing or all the brewhouse operations. Normally, what they do, there are different kind of configurations, but the principle basically is capture all these vapors that carry the thermal energy. They want to pass that energy thermal, they compress it into mechanical energy, and or they basically capture the energy in water reservoirs. So based on that, these whole water tanks reservoirs can be used for different operations. But what is key here is that you need to have a big footprint, because there are many components involved in these systems. And honestly, with you, at the end, you have surplus of energy, So normally these German breweries, German manufacturers, they sell you the idea, telling you that, okay, you're gonna generate surplus of energy, which you can even sell it to the municipalities. But we are talking here about, of course, breweries of, bigger size, like breweries that they're producing about at least above 30,000 hectoliters a year. So, and but anyway, it's important for your awareness, no, that there are these kind of systems, but of course they're expensive, And other thing is, that you can deal with, more efficient air compressors, chillers. Normally, large breweries, when it comes to cooling systems, they are dealing with more ammonia-based chillers because they are more effective, they are more cheaper, but there is a big problem here is the personal safety. Okay, so that's why most of breweries, craft breweries, small breweries, are dealing more with. They don't deal with ammonia, but they deal with a different type of coolants, glycol-based or different kind of refrigerants. So what else? Important things here. Lighting. Yeah, as I say, you can use LED lights, and I mean there is different, lighting, very efficient lighting systems that you can deal with. That I'm not expert, but you can always, DIY stores can even advise you on that. On constructors. Compressed air. This is super important. So this is important you keep in mind. So for every kilowatt of energy used or compressed air, just 12 to 15% is delivered to the source. So it's a huge energy loss. This is so keep an eye on air compressors, and any air leaks. So so as I mentioned earlier, do not use air for cleaning. And here's what I advise you is that you can get one, as you can see on the right-hand side, air leak detectors, this ultrasonic that you can see in this in that picture, and they're different range of prices. So you can get them the cheapest for 800 up to 30,000 crowns, or probably even more. But that really, they're very useful. So you can use this kind of device to detect the air leaks, because of course you cannot detect with naked eye. In the former times, remember 20 years ago, Mexico, in Modelo Brewery, Corona, they were using soap, applying soap in some leak in places, the potential places where there can be air leaks, and to see if they were bubbling, generating bubbles, So that's the only way they were doing back then. But now there are more sophisticated ways to do it. Now, when it comes to boiler heat recovery, some good practices is, as I mentioned earlier, so dealing with condenser return systems. So basically how your boiler works, I mean, as you know, so you need fuel to generate the energy to heat up hot water, or when it's basically a steam, and then the point is that the steam generates condensate, of course, so that condensate needs to be recovered going back to the system. So in simple words, but also when you are having combustion, during the heating, that exhaust gas, that you can see, can be also recovered. It can be used to reheat, with the use of a heater exchanger. You can reheat or superheat the water, So so this is basically the two components that you need to keep an eye, when it comes to boiler heat recovery practices. So here I can show you more or less how this works. So you have here the boiler, as you can see, and you have the stack economizer. So it's basically a heater exchanger where the exhaust gas goes through, and that one goes back is captured into to a storage water tank, you know. So it depends on the system. Some of them they're capable to do, as they call it, superheating, and some others just a normal heating. But you can really save a lot of energy. Now, when it comes to condensate, you can even you know, heat up the water from 50 degrees Celsius up to 100. So I know that some Swedish brewers do not have this. They normally have return systems, but they don't have exhaust gas economizers. But it's something you guys need to look into. Now, when it comes to this is what I was talking about, the pump sizing. So here, the classic problem that we face when it comes to pumping in general is just you need to make sure that we guarantee the net positive suction head, you know? So otherwise, we just wanna induce cavitation in our pumps. We're gonna damage the pumps, and also they will have problems even of foaming in the beer. We have beer losses and implications of quality and waste and energy. So it's very important that you have the right sizing of pumps. And in any case, it's not possible, or whatever you're doing, trying to go more of the oversizing range than going to the undersizing. Okay, that's just like for experience, you know. So don't take this like a rule of thumb. What else? As I mentioned earlier, condensate systems also can produce carbonic acid, you know. So obviously, because they're generation of CO2, so also can be corrosive, very corrosive. So it's important that the way your piping and your joints, that's important, that should be stainless. I know the stainless is more expensive, but if you use regular steel or another, you know, another piping material will deteriorate very quickly. So this is very common. So it's better that you have I would say, invest in your steam generation system with stainless steel. Actually, in general, as I've been talking in the previous lectures, the best investment you can do at your brewery when you want to set up your own brewery, according to my experience and my personal opinion, is first is your packaging line, not your brew house. It's your packaging line first, because also because it's something you're gonna run 24/7 all the time, and it's the most complex component of entire brewery. So you need to guarantee a good investment, that you have a great packaging line, then of course your brew house and your steam generation system. So in these three, you should not compromise. The rest you can, but definitely these three are really the major components of the entire brewery. So don't try not to be cheap when you're buying these three components, because you're gonna do a favor to yourself, because they're gonna last really long, and you will have less headaches, and it's gonna be, at the end of the day, much cheaper. So when it comes to insulation practices, as I mentioned earlier, everything is above 50 degrees Celsius. Now, obviously, go in priority list. So obviously, the hottest parts are priority. And here, what I advise you is to you can get thermographers, as you can see on the left-hand side. Again, these days they are not so expensive. There are many out there. So of course, some of them are better quality than others, but they're accessible in price, and also they will help you a lot, because also you cannot detect this with the naked eye, with the same with the air leaks. So think about it. And you will save a lot of money using these two instruments. So here I just will talk briefly about the energy management systems that you can implement in your brewery in order to have to ensure your good sustainable practices. So here in Sweden, there is the Swedish Institute for Standards. They have this energy management system called SSEN ISO 50001, implemented from 2018. Now, I came up with all this information on this slide because that standard is pretty much a ripoff from the German energy management system from back in 2010, the DIN 60001, which has been updated now for ISO 50001 energy management system in practice. So just I wanted to know you the background. So, but in principle, it's the same document. So these systems, the way how you implement it, the core of these systems, as you can read, are based on, you need to establish a plan, you take your actions, you review them, you check, and then in any kind of, and then and take actions, you know, again. So it's a circular way how to keep on check, you know, how you're dealing with your energy systems. And this is related also for environmental reasons, obviously. So here just give you some, normally you implement and you start see results after the third year when you're implementing this kind of systems. Obviously, this requires, I would say, a significant amount of manpower, you know, but so I would say for breweries, you know, I would say, I mean, you can always use it for any type of volume production, but I guess you might need someone, if not full time, at least more than 50% of the time just focused on this, you know, how to optimize the energy consumption in your brewery and to keep on check and give maintenance of the system. So so the action, how it works is, so the action plan starts first. You need to clarify that there are no energy consumption. We, including myself, of course, we can only say energy consumption, but the energy is, I mean, if we want to be very theoretical, it's energy conversion, because energy cannot be consumed. It's not created and not destroyed, as you know. It's just transforming. So so first you identify the responsibilities in the team, who is going to do what. You review the consumption and costs of your energy with your bills and everything else you have at hand. And then you start documenting everything. You collect all the data. You include the legal obligations, you know, and then you have a plan that you're going to execute, you know. So so this is pretty much the energy consumption. You review the consumption that you're doing based on the plans that you already established. And then you start evaluating your data, which I think this is the key, you know. So again, you need to establish your key indicators and how far you want to go with this. So you need to establish the parameters, you know, so about your energy system. So even if it's a very long document, you can make it adapted to your needs, you know, or your capabilities. So what you need to keep an eye is obviously your total energy consumption. Yeah. In terms of kilowatts normally, you know, and then you also your total energy cost, how much are you paying, you know, and how much you're capable to save, you know. So this is like a theoretical one before you execute the plan. You obviously, this is what they say, you need to do it through a SMART approach, which is a specific, measurable, appropriate, realistic, and time-bound. So you establish the time frame. So as I've been just repeating, maybe already a few times, it's like look at your production processes, implement new, new ways through your instrumentation and your equipment. Look at your utilities, you know, your HVAC and, you know, as I say, air, heat, and everything else. And also quantify for that time frame that you establish your payback time. So this is pretty much the system, which I guess just by reading it now, I guess for you guys, it's like, it makes sense. So, and well, this is just pretty much a repetition. The important thing here, I would say, this is on this slide is like the core of this energy management system standards. So you establish the target, you establish the parameters, your time frame, how much you're going to invest, how much you're expecting to save, and what is your payback time. Obviously, that will ask you your CEO and the shareholders. How much you're expecting to reduce of CO2 emissions, which is here is where it comes the connection between these energy management systems and the sustainable practices. And how will you measure it? Okay. So, and obviously, who are responsible? Normally, the energy managers, their CEO, I mean, for medium-sized breweries, the CEO is normally the responsible together with the production manager. Okay, because also the CEO needs to establish the targets. You know? So this is his responsibility or her responsibility. So but basically this is basically the core of these systems. So I think I reached now 10. I don't know if you guys have any questions now about it, or if you want to know some specifics that I haven't covered yet on these topics, please let me know.
Everything is clear.
Yeah.
Maybe if they have the lunch, maybe there are more questions afterwards.
Okay, good. So we meet at 1 o'clock. Is that correct?
Yes. And
okay.
I'm going to close down this all the meeting because so we could log in again, because then I can download the recording much quicker.
Perfect.
So now lunch break until 1 o'clock.
1 o'clock. Perfect.
Great.
Thanks.